The sky is the atmosphere of the planet. So if we want to study the effect of the atmosphere with the structure of the aircraft, then we need to define the outer boundary of the atmosphere, which is about 100 kilometers from the surface of the Earth. Above this height, the density of the atmosphere becomes extremely rare and can be considered as vacuum. And when the density of the gas is so low, the gases do not interact with any object passing through it. So, the atmosphere ends at a height of about 100 kilometers. Everything above that height is not related to the atmosphere. Therefore, it cannot affect the flight of the aircraft. So everything above 100 kilometers is called outer space. The word space was used to refer to the distance between the Earth and other planets, including the Sun. But nowadays, the word space refers to the region outside the atmosphere of the Earth. This part of the Earth includes the Moon, planets, stars, and galaxies, the Sun, and everything else that we see in the night sky. In physics, space is a three-dimensional extent in which objects move and interact. It is often considered alongside time as a fourth dimension in physics. Space is usually described as the boundless three-dimensional extent in which objects and events have relative positions and directions. It is the setting in which all physical events occur and is usually considered alongside time as a fourth dimension in physics. In modern physics, space and time intertwined in a four-dimensional continuum known as space-time are described by the theory of relativity developed by Albert Einstein. According to Newton's classical mechanics, space is absolute. This means that no matter where an observer is located, the laws of physics will be the same. However, Einstein showed that space and time intertwined in a four-dimensional continuum known as space-time are relative, meaning that the laws of physics will appear different to observers in different frames of reference. There are many ways to describe space. One way is to think of it as a set of points that have location or direction relative to one another. Another way is to think of it as a continuous medium in which objects can move. Still, another way is to think of space as a set of dimensions in which objects can exist. There are three dimensions of space: height, width, and depth. However, humans can only perceive two dimensions. So we use the third dimension to make sense of the world around us. The third dimension allows us to imagine objects extending in all three directions, even though we can only see them from two perspectives. In addition to the three dimensions of space, there is also time, which is often considered the fourth dimension. Time is a scalar quantity, which means it has a magnitude but no direction. The passage of time can be measured by counting the number of seconds, minutes, hours, days, etc. that have elapsed since a particular event. When discussing space, it is important to consider both its geometric and physical properties. The geometric properties of space include things like its curvature and dimensionality, while the physical properties of space include things like its temperature and pressure. These properties can interact in complex ways to create the phenomena we observe in the universe. One of the most important concepts in space is that of vacuum. A vacuum is a region of space that has been emptied of matter. The most common type of vacuum is a near vacuum, which is a region of space that has very low density of matter. Near vacuums are often created by removing most of the air from a container. They are used in a variety of scientific experiments, such as those involving particle accelerators or telescopes. Another important concept in space is that of gravity. Gravity is the force that attracts any two objects with mass toward each other. The strength of gravity depends on the mass of the objects and the distance between them. The further away the objects are from each other, the weaker the gravitational force between them. Gravity is what keeps the planets in orbit around the sun, and what causes objects to fall to the ground when dropped. In addition to these concepts, there are many others that are important to understanding space, such as electromagnetism, nuclear forces, and quantum mechanics. Each of these concepts plays a role in shaping the behavior of objects and phenomena in space. As technology advances, our understanding of space will continue to grow. New discoveries and insights will undoubtedly be made in the years to come. Whether we are talking about the vastness of the universe or the intricacies of subatomic particles, space is a never-ending source of wonder and exploration. For centuries, humanity has looked up to the stars and wondered about the nature of the universe. What is space? Where does it begin and end? Is there life beyond Earth? These questions have driven some of the greatest scientific minds to push the boundaries of human knowledge. With the advent of telescopes, we were able to see farther and farther into the depths of space, discovering new stars, planets, and galaxies. As we learned more about the universe, we began to develop theories to explain how it all came to be. The Big Bang Theory is currently the prevailing model for the universe, describing how it began from a hot, dense state and expanded over billions of years to the vast expanse we see today. But what exactly is space? Is it just a void? An empty nothingness? Or is it something more? Some believe that space is a kind of fluid, a substance that is all around us and that we can move through. This idea is supported by the fact that space can be compressed and expanded, as we see happening in the universe on the largest scales. Others believe that space is nothing but a series of interconnected points, a kind of fabric that connects everything in the universe. This idea is supported by the fact that space is relative, meaning that it is different for different observers. One of the most mysterious aspects of space is that it is expanding. As we look out into the universe, we are seeing objects as they were in the past, because light takes time to travel. As a result, we are seeing the universe as it was millions of years ago. And what we are seeing now is that the universe is expanding, that the galaxies are moving away from each other. This discovery led to the development of the theory of the Big Bang, which describes how the universe began from a hot, dense state and has been expanding ever since. The discovery that the universe is expanding also led to the development of the theory of dark energy. Dark energy is a hypothetical form of energy that is thought to permeate all of space and is responsible for the accelerated expansion of the universe. In recent years, scientists have begun to explore the possibility that space may have a deeper structure. This idea is supported by the fact that space seems to have a certain amount of rigidity, meaning that it resists changes to its shape. This property of space is known as space-time, and it is one of the key concepts in Einstein's theory of general relativity. According to general relativity, space and time are intertwined in a four-dimensional fabric that can be warped and curved by matter and energy. Another interesting aspect of space is that it has a finite amount of volume. This means that there is a limit to how much matter and energy can be contained within it. As the universe continues to expand, the total amount of space will increase, which could eventually lead to a shortage of matter and energy. This could have profound implications for the future of the universe. Despite all that we have learned about space, there is still much that we don't know. One of the biggest mysteries of space is the nature of dark matter. Dark matter is a hypothetical form of matter that makes up a significant portion of the universe, but it is invisible and has never been detected directly. Another mystery is the nature of dark energy. As mentioned earlier, dark energy is a hypothetical form of energy that is thought to permeate all of space and is responsible for the accelerated expansion of the universe. In addition to these mysteries, there are also many unanswered questions about the fundamental nature of space itself. For example, is space truly empty, or does it contain some kind of energy or matter? What is the relationship between space and time? And what is the ultimate fate of the universe? These are just some of the many questions that scientists are working to answer. As technology improves, we will continue to learn more about space and the universe we live in. With each new discovery, we will get closer to understanding the fundamental nature of reality. Whether we ever fully unravel the mysteries of space remains to be seen. One thing is certain: the journey of discovery will continue to inspire generations of scientists and dreamers alike. So next time you look up at the night sky, remember that the vast expanse above us is full of wonder and mystery. Who knows what secrets lie hidden in the depths of space?